Hello my dear students, this is Akash SD and welcome to the SD Physics classes. Hope so you all are doing really great. So students, in this video we are going to start the chapter Units and Measurement, and in this chapter we are going to see what is the measurement, what is the unit, after that what is the physical quantity, types of physical quantity, and how many fundamental quantities are there, what are the derived quantities is it, and at the end we will see dimensional formula of a few important derived quantities also. Okay, so let's start the video. So see here, under the measurement, let's see what is this. It is a process of determining how large or small a physical quantity is as compared to a basic chosen reference standard called unit. For example, if I choose the physical quantity length and I am taking the unit meter, and I am having the physical quantity 5 meter, that means this 5 meter is 5 times larger than 1 meter, is it? Similarly, if I am telling for example 0.5 meter, that means it is smaller, is it? So 0.5 times of the 1 meter, is it? So similarly we have written in the same way large or small. Okay, now after that, as I have told you, basic chosen reference standard is called what? A unit. But let's see in a detail what is the unit. Okay, so let's see. The chosen reference standard of measurement in multiples of which a physical quantity is expressed is called a unit of that quantity. Is it? In multiples of which, as I have told you, 5 meter means 5 times of 1 meter. If I am telling 7 kg means 7 times of 1 kg. So here the unit is a meter and kilogram respectively. Okay students, so kindly see this very well. Okay, great. Now let's see some basics. If I have taken here as example mass, how much is there? I have taken mass 5 kg. So if I talk about here, what is the physical quantity? So here you know physical quantity, the physical quantity is mass. After that, if I talk about here the numerical value is how much here? 5. Similarly, if I talk about here the unit in this, so unit is what is there? Unit means kilogram, or we can tell kg. Okay, so this mass equal to 5 kg is giving 3 information. Which physical quantity, what is the numerical value, and what is the unit. Okay, later we will see what is the SI unit also. Okay, second one, density given 1000 kilogram per meter cube. Actually this is the density of the water also at 4 degrees Celsius. Okay, so what is the physical quantity? The physical quantity is here density. Similarly, if I talk about your numerical value, you can see 1000, numerical value 1000, and unit, what is the unit is there? Kilogram per meter cube. Later we are going to see this is one of the fundamental unit and this is one of the derived unit. Okay students, so you kindly see here now how we have got it, what is the physical quantity, how to get numerical value and the unit. Okay, great. Now students, we are going to see what is the physical quantity, what is the basic definition. Okay, so see, we are going to see here, see, all the quantities which are used to describe the laws of physics are called physical quantities. Now, used to describe the laws of physics are called physical quantities. Mostly physical quantities are expressed as. So see here, I am writing here this physical quantity, I am writing here n into u. Physical quantity is what? N into u. Okay, see here please. What is the n? N is the numerical value. What is the u? Unit. Okay, and for example, see, if in any system of units are there, so in any system of units what will be there? This n into u will be always constant. What will be there? N into u will be always constant. Okay, in any, like later we'll see MKS, CGS, FPS, like that so many system of units we can make here. Or we can tell here as n into u is constant, so I can tell here n is inversely proportional to u. What is the meaning of this? The meaning of this is very easy. If the unit is smaller, numerical value will be large. If the unit is larger, numerical value will be smaller. Okay, like if I talk about here some examples. So I have taken your first example. Let's take, I'm telling that here 1 meter is equal to how much? 100 centimeter. You know very well. But if in case I will just take here the, let's take this numerical value n1, unit is u1, here numerical value n2, and here unit is u2. So what we know here? We know which unit is the larger. You know meter is more than centimeter, is it? So I can tell here u1 is greater than u2. So as U1 is greater than U2, what will happen at here? This N1 should be less than N2. Then only this N into U will be satisfied. Similarly, you can use for 1 kilogram equal to 1000 gram, and what we can tell, 1 meter equal to 1000 millimeter. Okay, in all the places what will happen, when the unit will get smaller, the numerical value will get bigger. Okay, that's why I'm telling that here N into U will be what? A constant. And what is this? N is the numerical value, and what is the U? U is the unit. Okay, students. So after that we are going to move for the next one. Okay, now let's see here. There are two types of physical quantities are there. How many kinds of physical quantities are there? Two types of physical quantities are there. First one, fundamental, or we can tell base quantities. Now let's see what is this. So see here, the quantities which do not depend on the other quantities are called fundamental quantities. Now, do not depend on the other quantities. Okay, now see here, the units of these quantities are called fundamental units, or even we can tell base units also. And I hope so you know somewhat more basics, is it? So how many fundamental quantities are there? There are 7 fundamental quantities are there. Now see here, we'll see later also, but see, length, second, what we can tell students, mass, third is the time. Okay, what is the fourth students here? Fourth is the electric current. No? Fourth is electric current. Fifth is temperature, or even we used to tell thermodynamic temperature, but here I will write here the temperature. Sixth, what is the sixth students? Amount of substance. This one is very common in our chemistry. Okay, amount of substance. And one seventh one is there. It will be very rarely will be using in a physics, but okay, we can tell luminous intensity. Okay, what is the students here? This is the luminous intensity. So there are 7 fundamental quantities. Later we will see there are 2 supplementary quantities and all this also. Okay, but please remember that here, this thing, 7 fundamental quantities. Okay, great. Now after that, second kind of physical quantity is the derived quantities. Let's see what is this. The quantities which can be expressed in terms of fundamental quantities are called derived quantities. Again, I'm telling, can be expressed in terms of fundamental quantities, and this thing is very important when we will write the dimensional formula of few derived quantities, because those dimensional formula will be always in terms of fundamental quantities. Okay, and see, the units of these quantities are called derived units. How many derived units are there? So many, so many, so many. Is it? Like fundamental I told 7 plus supplementary 2, but derived units so many. Okay, even if I talk about here, let's take if I tell here speed, is it? If I talk about here even velocity, this I am writing here the derived quantities. Even if I write here the force, or even if I write here the acceleration, is it? They all are which quantity? Derived quantity. Similarly, if I write here the work, now if I go to the 12th means, if I write here the what we can tell electric field, no? We used to tell electric field intensity, no? Electric field intensity. Now so many is there. 7. Okay, one more. Let's take here. I have written here the magnetic flux, no? Magnetic flux, power, charge. All of them are which quantity? Derived quantity. So how many is there? So many, so many, so many. Dot dot dot. So many is there. Okay, students. So derived quantities means they can be expressed in terms of fundamental quantities here. Okay, great. Now let's see after that system of units. System of units. So see here, what is this? A complete set of fundamental units, supplementary units, and derived units, which is used to measure all kinds of physical quantities, are called a system of units. Okay. Now, some of the very popular system of units in ancient time are following. Now, nowadays we are using SI. Okay, SI is the one form of the modified form of the MKS system. Okay, but some other was also there. Like if I talk about here, FPS, that means foot pound second. What is the system? Foot pound second here. Okay, so remember that here. F means foot. That is the what we tell unit of the length. Pound means unit of the mass. Second means unit of the time here. Okay, so remember that here. One thing here. If I write here, now if I write here the 1 foot. 1 foot, very very important, 12 inches. This one we used in a construction and all that. After that, students here, if I talk here how many centimeters are there? So remember that here, even this is used to be 30.48 centimeter. What I'm telling you students here, this is the 30.48 centimeter. Okay. Similarly, if I talk about here the pound, second one pound. Okay. So students see, this 1 pound. This 1 pound is used to be 453.6 gram. Okay, maybe some places it may be useful. So remember that here. Second means second as it is. Similarly, if I talk about here which one? Centimeter gram second. Very easy. And similarly, what is there? MKS system. That means meter kilogram second is there. But remember that here question used to come, in all these system of units, which physical quantity is common? So see here S, here S, here S. And what is this? Second. That means physical quantity time or unit second is common in all these three system of units. Okay. After that, students, fourth one, that is the very popular nowadays, now in modern time. What is this? International system, or we used to tell here what? SI. So what is there in SI? As I have told you, there are 7 fundamental quantities are there. What is this? Say there are 7 fundamental quantities are there and 2 supplementary quantities are there. Okay, what I told you? 7 fundamental quantities and 2 supplementary quantities here. Okay, so students, all these things you have to remember that. Okay, great. Now after that, see the very important table. Now very important table. So see here, fundamental quantities with their units. So I have told you very well how many is there? 7 is there. So see here, first one is the length. Base SI unit is what? Meter. METER, meter. Unit symbol M, and the dimension, for dimension always in a big bracket L. Okay, remember that. Next one, if I talk about here the mass. Mass means kilogram here. Now unit symbol kg, and here we used to write here with the capital M. Okay. Next one, time. Time means you know very well, it will be in a second. Even I told you previous also, in all the 3 systems, time or second is the common. And here what you used to write here, second means only S, and it is given here with capital T. Okay, dimensions. Similarly, if we talk about here electric current ampere. Okay, and here we used to write here capital A, and we used to write here the capital A. Even sometimes in some of the books and all, they can write I also, but most of the time capital A only. Next one is students, temperature. No? Here what is the base SI unit is the Kelvin. Other units are also there like degree Celsius, Fahrenheit, but what is this? Kelvin. And here we used to write here the K, and here also we used to write here the K. Sometimes they may use theta also, but K. And remember that one more thing here, the minimum temperature possible in this universe is 0 Kelvin, and the temperature on this Kelvin scale will never be negative. Remember that. Okay. Amount of substance is given by here mole here. Okay. So here mole, and here also just in a big bracket also we used to write here the mole. Last one, luminous intensity, very rarely will be used here, but write here candela. Okay, so here what is this? CD, and here also what we'll use here? We will use here CD. Okay students, so I hope so. These 7 fundamental quantities, they are the base SI unit, unit symbol, dimensions are very clear to you. Okay, great. Now students, after that, as I have told you, there are supplementary quantities are also there. How many? 2 supplementary quantities. So first one is what? Plane angle. So what will be there here? Their base SI unit is radian. Okay, and here also in a short form we used to write here the radian. Dimension, there is no dimension. Even I can write here M0, L0, T0. Okay. Similarly, if I talk about here the solid angle is used to be students steradian. And what we used to write here? Steradian in short form, and here also no dimension. This question is very common in NEET exam. They will tell some physical quantity, unit is there, but dimension is not there. So which are there? They are plane angle and solid angle. They are having units radian and steradian, but they are what? Dimensionless. Okay. After that, students, here I want to tell you this plane angle separately. So what is the plane angle, students? Here just remember the formula please here. The formula is that this angle equal to arc by radius. Okay, even in my basic maths video also I have what to tell, we have just seen this. So angle equal to what? Arc by radius. Let's take for example, if this any arc is there, okay, and here if I take here this angle theta, now radius r, and length what we can tell L. So we can write here, students, we can write here this theta equal what L by R. Angle equal to what, students, here? This one here. And as I have told you very well here now, what is the SI unit? Radian. Okay. After that, just remember that one thing here. This used to be, no? So if I talk about here like this here, like 360 degree is used to be the 2 pi radian. What I'm telling, 360 degree is the 2 pi radian. Or this is also very common, like if I write here the 180 degree. So 180 degree is used to be, how much is there? Pi radian. Okay. At least this basics you have to just remember. That's it. SI unit is the radian only, but sometimes angles used to represent in a degrees also, na? That you have seen it number of times. Is it? Now, students, after that we are going to see important dimension formula. Okay, we will just learn how to just do here. See, first one is, students, if I write here for the speed, what I am going to write here? I am going to write for the speed, or even for the velocity also. Okay, either speed or velocity, both is same. Okay, so remember that here we know very well, speed means distance by time. What is the, students, here? Speed means distance by time. Okay, and after that, if I write here this speed, S equal to distance means L, and time means T. So we can write here what? LT minus 1, or in a very standard form you can write here M0, L power 1, T power minus 1 is there. Okay, or we can tell dimensions of speed is 0 in mass, 1 in length, and minus 1 in time. Okay, even same for the velocity also. As I have told you, for the velocity means displacement by time. Okay, and here also same dimensional formula will be there, nothing else. Okay, after the students here, if I write here the acceleration, what is this? Acceleration. Okay, so students, for this acceleration, what will happen that here? See, first we should know the formula. See, one formula will use. See, V equal to U plus AT. So what is the acceleration here? V minus U by T. Okay, so students, after that, if I write here the dimensional formula, so dimensional formula, what will happen that here? See, when your dimensional formula, always in a big bracket. Okay, so for the final velocity, LT minus 1, minus initial velocity, LT minus 1, and here time is what? T. Don't think so LT minus 1, LT minus in 0. No, this is just a unit. Okay, that means we can write here LT minus 1 by T. Okay, so what this will become here? It will become here LT minus 2 here. Okay, even here maybe confusion come. Okay, but still I want to tell you. Let's take for example, if I ask you 7 meter per second minus 6 meter per second, how much is there? Okay, so the answer will be how much here? 1 meter per second. So you can see very well, students, here unit is meter per second, here unit is meter per second, and here final answer unit is what? Meter per second. So whenever we are writing in big bracket means that is the unit. Okay, students, so I hope so this is very clear. Okay, now after that we are going to move for the next one. Okay, so see, third one we are going to write for the force. What is this? Force. So you know very well, students, here we know that, see, force means F equal to mass into acceleration. We are writing some important, because so many derived quantities are there, we can't write for everyone, but okay, I'm just telling you how to do it. Okay, so what will happen that here? Force means, okay, unit means F, dimensional formula, M means mass, capital M, acceleration means what is this? LT minus 1. Okay, so when you will write here, it will come here LT minus 1 or 2. So MLT minus 2. Okay, after the students here, fourth one, force we have done. Let's take for example, I am going to do for the pressure even. What is this? Pressure. So pressure, what will happen that here? Again, the students, you know very well what is the pressure. You should know the formula to write the this dimensional formula. Normal force by area. Okay, so what will happen that the students here, if I write for the pressure, so force means what we know, MLT minus 2, and area means, you know, na, meter square, centimeter square, so what we can tell here, L square. So what this will become here? It will become here ML, here power 1 minus 2, minus 1, and T power minus 2. Is it? So even you can see for this also. After that, students, here, see here, if I write for the fifth one, I'm going to just take here, for example, electric field, or let's take here, first I am taking here electric charge, then we can go for the next one. So to calculate for the electric charge, you know very well which formula we are going to use, I equal to Q by T. So what is Q? Q is given here IT. So if I write here, dimensional formula means Q, current means A, time means T, then what this will come here? It will come here the AT. What will come? 80. Is it? That is for the electric charge here. Okay. So we have seen 5. Okay. Next one is students here. If I write here, sixth one. Now I am going to tell you electric field intensity. What is this? Electric field intensity. This is used to come in the first chapter of the 12th under the electric charges and fields. Okay. So for that, students, remember that here this electric field intensity is given by the force per unit charge in a vector form. Even we can put here the vector also, but that is a different game. Okay. So what will happen that here if I write here the dimensional formula? So E equal to force means, as I have told you, what? MLT minus 2, and charge means what? 80. So students, when you will simplify this, what will come here? MLT power minus 3 A power minus 1. Is it? So what is this? Electric field. Okay. Next one is students, if I write here for the, let's take for example, electric flux. What is students? Electric flux. And later you will see that for the electric flux, area is considered as a vector quantity because orientation of the area matters. So this flux is given by here phi equal to EA cos theta. Okay. As I have told you, vector quantity area, so vector E dot A. So students, here if I write here for the electric flux, this phi is given here. Electric field, what I told here, see, ML T power minus 3 A power minus 1. Area means, see, mistake happened, na? L square here. Okay. Cos theta, trigonometric function, no dimensional formula. So what this will become here? This will become here ML cube and here T power minus 3 and A power minus 1. Okay. All this we have done, but see here. Let me write here the 8th one. That is also very important. Okay. Let's take for example either work or energy. What I am telling, either work or energy. So students, you know very well, work is given by W equal to FD cos theta. Okay. So if I write here the dimensional formula for the work, always in big bracket, force means MLT minus 2 and displacement means L. So what this will come here? It will become here ML square T power minus 2. Very, very important even for work, energy, and even if I tell torque also. All of them are having same dimensional formula, na? That's why I have told you. But does not mean that all the physical quantities are having the dimensional formula. Some of the physical quantities are dimensionless also, like refractive index, relative density, and all that. Is it? So let's take for example, if I am writing for the refractive index. Now this is a very common where in a optics. So what we studied here, refractive index means speed of light in vacuum by speed of light in a medium. Okay. So students, if I write here that this dimensional formula mu, so what this will become that here? See, here LT minus 1 and here also LT minus 1. So what this will become here anyhow? L power 0 T power 0. But remember that here this refractive index, there is the no unit and no dimensional formula. But I have told you plane angle and solid angle, there is no dimensional formula, but they are having the unit radian and steradian. That's why regularly they are asking in a NEET and J exam. So students, I hope so. Can you see here? Very well. So I hope so students, all this basics and all you have understood very well. Thank you so much. Keep studying, keep going.